Today we will continue our discussion on bisection method. In the last lecture we have seen how to solve a problem, how to find the root of a nonlinear equation by using bisection method. So today we have another equation. For example, we will see another example. We will see a transcendental equation. Okay, so I will give an example. You have an nonlinear equation f of x is equal to e power x minus 3x. So this is a transcendental equation. Okay, this is a transcendental equation because it contains the term e power. Okay, and given that the root is between 1.5 and 1.6. okay, and obtain the solution such that the error is less than 0.002. That means you have to find the solution in such a way that the error is less than 0.002. So to proceed with this problem, first of all we will be finding what is this f of 1.5 and f of 1.6. So f of 1.5 means e power 1.5 minus 3 into 1.5. So you will get this answer as minus of 0.01831, I think. Okay, minus of 0.1831, I think so. Let me check. Okay, 183. Okay, that's it. Now you can find, similarly you can find what is f of 1.5, 1.6, which is nothing but e power 1.6 minus 3 into 1.6. So you will get this answer as 0.1530. okay, so you can see here. Now it's very clear that this answer is negative and this answer is positive. So the root is between. So the root is there between the points 1.5 and 1.6. So this is your A and this is your B. Now we will proceed with this. So I will use the next page. So I will write the function again. F of x is equal to e power x minus 3x. Okay, now our A equal to 1.5 and my B is equal to 1.6. Now we will proceed with the same table, the iteration index. Okay, iteration index. I will start from here because if we need more space then it will be a problem. So this is my A, then this is my B. Okay, I will find f of A here itself, f of A. Okay, now my B, then f of B, the new solution, xs1 is my new solution, f of xs1, then my error, which I can say my error epsilon or delta, you can say in any, you can use any notation. Okay, now we will talk about the first iteration. Okay, then I will second iteration, third iteration, fourth iteration, fifth iteration, and the sixth iteration. Let's see. Now for n equal to 1, so we will start with n equal to 1. Now our A was 1.5 and f of A we have already found it as 0.183 minus of 0.183. Now what is B? B is 1.6 and f of B we have already found 0.150, 0.1530. 0.1530. Now we will find the new point xs f of b 0. Sorry, I have written in a wrong place. Okay, so this is 0.1530. Now I will find my new point xsb as this one is a plus b by 2. That means in bisection method we will use like this. So bisection method, since we are using the bisection method, we will find our xs1 by using a plus b by 2. So a plus b by 2 is 1.5 plus 1.6 by 2. You will get this answer as 1.55. Okay, now you see here you can find f of xs1. F of xs1 means what is it? Is nothing but e power xs1 minus 3 times xs1. This is the equation, because you know what is f of x. So this will become 0.0615. So 0.0615. Now what is the error? Actually error is nothing but, you can take anything b or a, whatever. B minus xs1 is the error. So it is nothing but you had actually this is 1.6 and this is 1.55. If you take the difference, you will get the error as 0.05. Okay, now you see here that this value is positive. Okay, and your b is also this is f of b is also positive, and f of a is not positive, it is negative. So where is the solution? So you see this point first, your new point, and this is positive and a is negative, so you will take this one also. So you will take the a as the same a 1.5, and your b is the new b, because this is positive, because this is negative, here it is negative, and so I am taking this value, and this is positive, so this is positive, so I am taking this value now. So I will take this value now here, this become as the new b. Why I am taking like this? Because my f of a is positive now, and f of x's is negative now, and f of b, what is f of b? F of a is not positive. F of, sorry, I have f of a is you see f of a is negative and f of b is positive, and f of x's is what is f of x's is positive. Yes, so this is how the graph is actually going on. The graph you can plot like this. This is your a and this is your b. You see f of a is less than 0, this is your 0, and this is f of x, and this is x, and here it is f of b, which is greater than 0. Now you have got your new point. Where is that new point? It is the average here. Okay, and your new point is positive. You see here f of x's is positive, so new point is actually giving a value positive. So here is your x's, which is nothing but a plus b by 2, is the actually almost in the middle. So you see here the solution is here. This is the solution. So the solution is between a and x's, and there is no solution actually if you take any point here. If you take any point between x's and b, no solution, but the solution is between a and x's. That's why I choose my new interval. My new interval is nothing but I will choose my a. I will choose my a because a is negative and the x's is positive, so I will choose this and this. Okay, and my b is nothing but our x's, new x's. So new b is nothing but our x's. So this is my new interval. So I am choosing my due b as x's. That's what I have done here. Now f of a, you know what is the value. It is nothing but, so it is nothing but f of a is minus 0.183, and f of b we have already found it because this is 1.55, so we have already the answer, this one, that is 0.0615. Now I will find my new x's as the average of a and b. That means I will take 1.5 plus 1.55 divided by 2. So I will get this answer as 1.525, and I will find the value of x's, f of x's as 0.0201, and this value, of course, it will be divided by 2, because you see in the next iteration you are taking this point and this point. After that you are finding the new x's somewhere here. This is your x's, okay, your x's is somewhere here, okay, your x's is somewhere here in between this a and b. So it is nothing but the average. So you will get here as 0.05 divided by 2. Again it is divided by 2. So what is this value? I can write this value as your initial b minus a by 2. That means that I can write the 0.05 in another way. It is b minus a absolute value divided by 2. So this is nothing but 0.1 divided by 2, which is equal to 0.05. I will write it here. This is equal to 0.1 divided by 2. It is equal to 0.05. Now it's become 0.05 by 2. So or I can say this one as the previous value was 0.01, sorry, 0.1. Now again it is divided by 2, right? So this will be going in that way. Actually I can write before completing itself 0.1 by 4. Okay, this is 0. So in the first iteration you are getting actually 0.1 by 2. So in the first iteration you can say that it is nothing but b minus a by 2. It is b minus a by 2. So 0.1 by 2. This is 0.1 by 4. This is 0.1 by 8. 0.1 by 16. This becomes 0.1 by, again divided by 2 means 32. 0.1 by 64. It is going like that. So you don't need to calculate it again and again. If you know what is b minus a, you can easily write like this. Now we will see that we have seen that this answer is positive, okay, 415.25, and this answer is negative. So the answer is between a and new x's. So because this is positive, so there is no answer, there is no solution or root between b and x's. So we have the solution between our new x's and b. So new x's and a. And what is our a? Our a is same, 1.5, and this is positive. So what is the corresponding value? The corresponding value is 1.525. Okay, 1.525. Now f of a, we can already find it. It is already the same, 0.183. We don't need to find it again. And f of our new b is also, we know, 0.0201. okay. Now we can find what is the average of this. Next we will find the average of this. I will just write, that means average of this one, sorry, not this one, the average of a and the average of, that means the average of a and b, that means a plus b by 2. You will get it as 0.00056, okay, 56. Now not 56, I think, sorry for this. You will get this answer as 1 point, average is nothing but between these values, 1.5125, and f of that is nothing but 0.00 0.056. Now it is clear that this value is positive and f of b is positive, f of a is negative. So again the solution is between a and x's. So our new a is our old a, again 1.5, and this is positive, so our new b is x's. New b is x's 1.5125. Okay, now f of y12 is 0.0056 and this is minus 0.183. Okay, 0.183. Now our new x's we will find as the average of these two, a and b. That means I will take this a and this is b. I will add all a and b and then I divide by 2. Then I will get the answer as 1.50625. 50625. And f of x's I will find it as the f of x's I will get it as minus 0.0090. Okay, now you see I have got the answer which is negative again, and I have got my f of b as positive and f of a is negative. So where is the answer? So first I will take this guy and this is negative, then I need actually a positive number. So what is that positive number? So I will just write here 1 2 3 4, then this is the 5th iteration and then 6th iteration. So this is negative, so I will search for something which is positive. If this is positive as in the previous iteration, I will search for something which is negative, but here I have something which is negative, f of x's, so I need something which is positive. It is nothing but b. So my b is this is my b. Okay, this is my b. So you see here that my x's is now my x's is equal to xs1 is equal to, I will just write it, my xs1 is equal to 1.50625, 1.50625, and f of x's is negative, right? F of x's is less than 0 or negative. Now what about my b? My b is 1 point, actually my b is positive, means that it's positive here, f of b is positive now. So my f of b is positive, my b is 1.5125, so my b is 1.5125 and f of b is positive. That means that if I draw the graph, okay, my b is here and my f of b is greater than 0 and my graph is going like this, okay, and this is where my x's is there here, and f of x's is less than 0. That means that my solution is between these two. My solution is somewhere is here, this is my solution. That means my solution is between b and x's. Okay, and where is my x's? Okay, it's not like this anyway. It is because you see the b is a small number, sorry, x's is a small number and b is a large number. So my b will be here anyway. This is my b, so it is not like this. So if I plot like this, this is my b and my b, f of b is greater than 0 and this b is 1.5125 and x's is somewhere here. This is my x's equal to 1.50625 and f of x's is negative. That means this is negative. F of x's is less than 0. So my solution is between these two. My solution is here. This is my solution. So I have to choose this interval. So what is the first value? The first value will come x's because this is the small number. And what about b? This become a large number. Okay, this is the large number. So first I will write the x's, after that I will write my b. So I will write my x's first. My x's is 1.50625 and my b is new b is nothing but the old b, 1.5125. okay, and I know what is the value, 0.0056, and 1.5025 has the function value which is negative minus 0.0090. so I got it. Now I will find my average. So what is my average here? My new average is 1. If you take the average of b and x's, b and a, you will get the average as 1.5094. okay, you will get this, and the function value become 0 minus of 0.0042. now you see here again that this value is negative, so I need something which is positive. So positive is again b, so I need to choose my x's and b. So what is my x's? X's is the largest number. This is the x's is the small number when compared to b. This is a large number. okay, so I will write my x's first. That's why I am writing here also the x's first. okay, I will write my x's first, 1.5094. and what is f of x's? It is nothing but 0 minus of 0.0042. okay, and then I will write my b. so b is same 1.5125 and this is same 0.0056. then I can calculate my new value for my x's, and what is that? It become 1.51094 and f of that is nothing but minus of 0.000017. okay, so you see here that I can continue like this. If I need more iteration, I can continue like this, but in the question it is given that the error should be less than 0.002. that means that what is this value you are getting? You see, I have given already that the error is propagating like this, 0.1 divided by 32. You will get this number as you will get this number actually as 0.0003125. but this number you will get here as you will get this answer as 0.00156. so in the question the error should be less than 0.002. that means that you can stop now, because now it is 0.001 and this 0.00 you can stop here. It is because this error now is 0.00156, which is less than 0.002. so stop the iteration. Now you can stop. So if you stop the iteration, where is the answer? If you stop the iteration, your answer is our new x's. This is our answer. okay, this is my solution. x's is equal to 1.51094. so this is how we are finding the solution to a nonlinear transcendental equation. okay, so now the root is actually, you can say that the root is almost correct up to 2 decimal places, you can say. okay, now this is the answer. So what I am doing here in throughout the problem, so the procedure is like, suppose you have a function, you have some a and some b here. Now you will find the axis, at the center. That means axis will be at the center, which is a plus b by 2. After that you will find f of x's. okay, and this f of a is less than 0, and this f of b is greater than 0. That is why the solution is between a and b. Now f of x is greater than 0, so there is no solution in between these two, but there is solution between your x's and a. So the solution is here. Here there is the root, because this is the solution. So our new interval, we will again we will come to the new interval again. So I will plot this, okay, and this is your x's, and this is your a, and this is your f of a, which is less than 0, and f of x's is greater than 0. And this new x's, I will call it is my b. I will call it my b. This is my new x's. That means our x's, I will call it as b. Now what I will do? Now I will find the average of this. So my average will be here, a plus b by 2. That means this is my x's, which is nothing but a plus x's by 2. It is my average, and I will find the function value x's. But this f of x's is less than 0. So, and this f of b, now it is b, f of b is greater than 0. So my solution is between now new x's and my b. My solution is between these two. Okay, so here is the root. The root is between x's and b. Now there is no root between a and x's, because f of a is negative and f of x's is negative. Now my root is between x's and b. So I will write it again this like this. My root is between my x's and my b, and new x's I will call as my new a. This is my new a, and I will find the average of these. It may be somewhere here. So this is my a plus b by 2. This is my new x is 1. Okay, or the solution. So this I will call it as a. Now I find it. Now this is f of x's, which is greater than 0. This is f of b is greater than 0. F of a is less than 0. Since this is negative and this is positive, my root is between a and x's. So I will assign my new a as this a and my new x's as b. So I will take the interval again. I will take this interval again. So this is my function. Okay, I will take, this is my b and this is my a. Now I will find the average as the new solution x's is equal to a plus b by 2. So you see here, as I proceed, the length of this piece is decreasing. That means I am approaching to the solution. I am getting the solution. So if I have a solution, now I am saying my solution is here, a plus b by 2. So what is the expected error? The maximum error I can get here, this is my epsilon, or I can say error. So my error is always actually x's minus b absolute value divided by, okay, this is my error actually, or I can say it is nothing but b minus a divided by 2. So what is happening in the first iteration? In the first iteration, you have the solution is between a and b. So the error, you can actually initially you can expect the error of b minus a. But in the first iteration, what will happen? You will find in the new solution is equal to a plus b by 2. That means you have the piece a here and this is your b. Now this is your x's. So the maximum error is this much, or the maximum error is this much. That means your maximum error epsilon is equal to b minus x's, the absolute value, or a minus x's, you take the absolute value. So in the first iteration, you are getting b minus a divided by 2 as the error. Okay. Now in the second iteration, this is my error, and this is my maximum error. Or I can say in another way, in the first iteration, my error will be always less than or equal to b minus a by 2. So this is the first iteration. Okay, in the second iteration, my error is less than or equal to b minus a. Again, I will be dividing into 2 half. So it is nothing but b minus a by 4, which is equal to b minus a by 2 power 2. So in the third iteration, my error will become b minus a by 2 power 3. So in the fourth iteration, my error will be less than or equal to, so I will just use the absolute value to just to show the magnitude of the error. Okay, this is the magnitude of the error. So b minus a divided by 2 power 4. Like this, in the nth iteration, I will get my error which is less than or equal to b minus a by 2 power n. So this is the equation for the error. So if that means that is error is less than or equal to b minus a divided by 2 power n. Okay, n is the number of iteration. N is the number of iteration. Okay, number of iteration. That is, this is the formula. Suppose you can have one example. Suppose you need a solution or the root, okay, solution which is having an error less than or equal to 0.01, means that your error is 0.01, okay, which is less than or equal to b minus a by 2 power n. From this you can calculate, actually, if you solve this equation, solve and find n, how many iteration you need. Okay, so here I will show you. If you need an error which is less than or equal to 0.01, then it becomes b minus a by 2 power n. So I can write like this: 2 power n is less than or equal to, I will move this here and I will move this here down. So modulus of b minus a divided by 0.01. So I will take the natural, I will take the log to the base 2. So log to the base 2 of 2 power n is less than or equal to log to the base 2 of b minus a by epsilon. Okay, that means that this is nothing but n, which is less than or equal to log to the base 2 of b minus a by epsilon. Okay, this is the logarithm to the base 2. So this much number of iteration you need, otherwise you cannot get an so in our case, actually, in for epsilon less than or equal to 0.01, our number of iteration which is required is nothing but log to the base 2 b minus a divided by 0.01. So this much iteration. If you know b and a, if you know b, a and epsilon, you can calculate the number of iteration needed. So according to that, you can see how many iterations are needed, or we can say that how many here you see in this problem I have used 6 iteration. Okay, like this, how many iterations are needed for the problem can be easily calculated by using this formula. So I can write this formula in another way also. So I will write this formula in another way. Your n is less than or equal to log to the base 2 of b minus a divided by epsilon. if I am using, this is the log to the base 2 formula. This formula, this is the logarithm to base 2. If I need another one, n is less than or equal to logarithm of b minus a by epsilon divided by log of 2. This is the formula. This logarithm is in the logarithm to base 10. Okay, so in your calculator you have to use this formula, because there is a conversion from log to the base 2 and log to the base 10. So this is the speed of number of iteration required, or it is giving you the speed of convergence of this algorithm. Okay, I hope it is clear to you. So in the next class we will discuss about another method, which is known as the regular falsy method. Okay, so before that I will give you an homework problem for practicing, only for practicing. So what is that? F of x is equal to x power 6 minus x minus 1. It is an algebraic equation. So find the root of this equation, root of f of x, accurate within epsilon is equal to 0.001. That is the error. So use bisection method to solve. Okay, so you and assume that the solution is between where is the solution? Actually the solution is between 1 and 2. That means your a equal to 1 and b equal to 2. Okay, so please try to solve this problem. If you have any questions, you can message me through the course message. Okay, thank you.